In one of the previous tutorials, we saw how we could open up a WAV file and play it. And so we've got the same type of thing happening here. I've got a WAV file called flute.wav. It's somebody playing the flute. And I can easily hear it in the background there. If I press a 0, it presses stop. Now, in this tutorial, what we want to do is we want to change the pitch of a particular sound file. Unfortunately, the readsf object isn't flexible enough to do that. What we need to do instead is we need to get the flute.wav file and get the data and feed it into something much more malleable. And the place where we do that in pure data is in an array. So I'm going to delete what we have there and I'm going to start again. I'm going to put in a message box. This time I'm going to say read, and I'll call the sound file flute.wav, and I want to put it into an array. Now I haven't created this array yet, but I know I'm going to call it sound data array, and I'm using camel case there. So let's create the array. I'll put in the put menu and I'll go to array, and I want to call this new array sound data. I'll rename it there. And I'll just put on Bezier curve, that's my preference. Click OK, and that is the array, and it's been created. I'll push it over there to one side because I'm going to need a bit more space than that. The message by itself is just a message. It isn't actually doing anything, it's not an object. The object that actually gets this flute.wav file and gets the data and puts it into the array sound data is called soundfiler. Very powerful object, and if you want to know more about it, just go into the help menu for it. So I'm going to connect those two together, and if I run it and click on the read message, nothing especially good happens, and that is because the actual flute.wav is too big for the sound data array that I've created. So I'm going to put in another message here just before the actual name of the file called resize, and I'll click it this time, and I see now that the data has gone into the sound data array. Something else that the soundfiler does, it puts out a piece of information through its outlet, and that is how many samples are in this particular sound file, and that is something that we're going to need to use. So if I click on the read message box again, I get a plus there in that number box. I'll just change the properties and change it to 10. The reason we were getting that plus was there wasn't enough space in the number box to see the number of characters. And so I see there's 543,744 samples in this particular file, flute.wav. The next part of this jigsaw is I'm going to use the phasor object. And phasors are a great way to get the data from an array and map it onto a phasor sound wave that's been created, and the phasor can take the shape of the data of the array. So I'm going to create a phasor object there with a tilde, so that's ready to go. I'm going to multiply this wave file by a certain expression as well, and we'll see why that is in a minute. I'm going to map that onto whatever is in tab read. So I'm going to read whatever's in the sound data array, and I'm going to push that out to the DAC object. Now, nothing's going to happen yet, and the reason why nothing is going to happen is because I need to tell phasor what rate to actually read the array sound data. Without that information, phasor is a bit lost. It doesn't know what speed to actually attack the data and go through it. And the rate is related to how many different samples there are. So this number up here that came out of the outlet of soundfiler when I opened the file. Now, taking that the wave has been sampled at 44.1 kilohertz per second, I am going to put in an expression here where I take 44.1 kilohertz and divide it by whatever the actual sample was that came out of soundfiler. So $F1 will be the same for that, and I'm just going to join that up. So that will take this number and divide it into 44.1 kilohertz. This is the rate that I want the phasor to read sound data. I also want to multiply the signal that comes out of phasor. I want to multiply it by the number of signals or number of samples that there are. So I'm going to take from that number box that is the outlet of soundfiler. At the moment for this particular file it's 543,744 samples. I'm going to get the phasor to take that number of samples so it maps onto the exact number of samples that are in sound data. And by doing that, now if I actually load in flute.wave into soundfiler, that whole process will cascade down onto phasor, rereading what the data is that goes into sound data and playing the sound file. There we go. Now that will keep looping, so I'm just going to put in a 0 message box here in phasor so I can stop it. What we have here is this sound file, flute.wave. It's roughly 12 seconds long, 12.3 seconds long, and you'll get that if you take the number of samples, 543,000, and divide it by the sample rate, 44.1 kilohertz, to get through that sound file, it's going to take 12 seconds. What this expression here is doing is it's kind of saying, well, if I take 44,100 and divide it by the number of samples, 543,000, I'm going to get 0.018, and that's telling phasor you need to take the amount of data that's in sound data array. You need to take 0.018 every second of that so you can crunch through it in 12 seconds. And so this expression object is churning out the value to keep the pitch. So phasor is going to jump through 0.08 of this sound data array, the data that's in it, 0.08 of it every second. And after 12 seconds, it will have munched through the whole lot and thrown it out through the DAC. What we want to do is we want to manipulate that figure, 0.08. We can say, well, I want you to jump through more of it at a given second so that you'll get through the actual sound data faster, and therefore the pitch will be higher. Or I want you to slow down and take less than 0.08 so that the pitch will be slower. And so to do that, I'm going to put in a horizontal slider. Horizontal slider, H slider, and the range that I want to put in on this is, well, 0.08 is the middle ground, so really depends whatever way I want to set it up. So I'm going to go between 0 and 1, and let's see how that sounds. So I'm going to apply that, click OK. I will push that in at the same point where the value came in from this expression object here, and we'll see how this works. So play the file. So you can see I'm manipulating the actual pitch there. Let's put in a number box so we can see exactly what the number is that I'm actually pushing out there. So that's approaching normal because it's coming closer to 0.08. So I'm changing the rate at which phasor is crunching through the actual data, the sound data array. And something else that I can do is not only can I go in forward directions, but if I manipulate the properties of that H slider, and instead of going between 0 and 1, let's say I go between minus 0.5 and plus 0.5. Then not only can I go forward, but I can slow it down and actually go into reverse. So that's in reverse. And I can go back over and put it forward again at certain rates and speed it up and slow it down. So that's the pitch changer in pure data, and it's all to do with the soundfiler object and also mapping it onto the phasor object that reads the sound data array and pushes it out at a different rate.